this is class 12 chemistry and you are going to see the electrochemistry unit. Okay, so now what is electrochemistry? The flow of electrons will lead to chemical reactions. Okay, the flow of electrons will lead to chemical reaction, and those chemical reaction are used to produce electrical energy. Batteries are devices which are using the chemical reactions for the production of electrical energy. Okay, first I am differentiating what is battery and what is cell. Okay, a cell is composed of only anode and cathode, but battery is the combinations of cell. Batteries is the combination of two or more cells combined in a series. Okay, so that is the main difference between the battery and the cell. Now I am going to say the components of cell. What are the things present inside the cell? The main thing is anode. We know anode is a positively charged electrode. Anode is the positively charged electrode responsible for the oxidation. Here I have written anode is a positively charged electrode responsible for oxidation. Oxidation is nothing but the removal of electron. Then cathode. Cathode is the negatively charged electrode which is responsible for reduction. Reduction is nothing but the addition of electron. Okay. What is the electrolyte? Electrolyte is the salt of either anode or cathode. Then we need an external circuit. The external circuit is used to connect the anode and the cathode externally through and the power is connected to you measure in terms of voltmeter. Okay, the salt bridge is the connecting thing between the anode and cathode internally. This external circuit is used to connect anode and cathode externally. Salt bridge is used to connect anode and cathode internally. If needed, we will use the salt bridge. Okay, now I am going to say the Daniell cell. So the Daniell cell we have learnt in your class 11. Okay, so this is a basic reaction present in the Daniell cell. Zinc giving zinc on addition with the copper ions gives zinc ions and copper ions. Remember, this is a redox reaction. What we call as the redox reaction? When oxidation and reduction occur simultaneously, then that will be called as the redox reaction. As a result of this reaction, we are getting a EMF, that is electromotive force, as 1.1 volt. This redox reaction I have written the anode and cathode reaction separately. Okay, zinc giving zinc ions. So this is the oxidation reaction, and the cathode copper ions combine with the two electrons to give copper, that is the reduction. Okay, so this is the Daniell cell, and now I am going to discuss three cases. Suppose I am supplying an external potential to the cell. What happens? Already we know the external potential, the EMF gained in the Daniell cell is 1.1 volt. Okay, suppose I am supplying external potential less than that of the 1.1 volt, means then the cell is said to be the electrochemical cell. Okay, what is the electrochemical cell? The reaction happens as we described earlier, that is zinc combined with the copper ions to give zinc ions and copper. This is the normal reaction. It will happen when we supply electrode potential less than that of the 1.1 volt. Okay, in case 2, if suppose if we supply external potential equal to 1.1 volt, means there would not be any movement of electron. In case 3, if I am supplying external potential more than 1.1 volt, means what happens? The cell turn into electrolytic cell. What is the electrolytic cell? That is the reverse reaction will happen. What is the reverse reaction? Here I have written the reaction. I am going to write the left hand side as right hand side and right hand side as the left hand side. So I have written here the zinc ions and copper in this side, and the reactant side is I am writing as the product side. This is the reverse reaction. This will happen if the external potential is more than the 1.1 volt. Okay, now we are going to discuss about the half cells. What are the half cells? Half cells are one which contain only one electrode in it. Okay, so this is the anode half cell. In this anode half cell there is a electrode which is the anode, that is here I have taken zinc as an example. Okay, in the electrolyte we are having zinc sulfate solution. Okay, this zinc sulfate solution immediately dissolute to form zinc ions and sulfate ions. Remember, the anode is the positively charged electrode, as we said. So this positive charge electrode I have drawn here, and this sulfate ions. Okay, what happens if the electrode is positively charged, then it would attract the negatively charged ions. So the sulfate ions will be in the immediate vicinity of the electrode. Okay, so the sulfate ions will be present in the immediate vicinity of the electrode, and this will combines with the zinc ions. Where the zinc ions will be, this zinc electrode, it has a tendency to lose their electron and will become zinc ions. This zinc ions combines with the immediate neighborhood sulfate ions to form the zinc sulfate ion. Again the zinc sulfate dissolute to give the ions. Okay, this is the reason for the potential. What is potential? We can simply define it as, potential is the tendency for element to gain or lose electron. Here the removal of electrons happens, so it is called as the oxidation potential. Okay, now coming to the cathode half cell. In the cathode half cell I have taken the copper electrode. Okay, so this copper electrode, and this copper electrode receive 2 electrons from the anode compartments. From the anode compartment it is getting what? 2 electrodes through the salt bridge. Okay, suppose if the 2 electrons enters into the copper electrode, this will immediately combines with the 2 electrode, copper sulfate present as the electrolyte. Okay, this copper sulfate will dissolve to give copper ions and sulfate ions. Okay, so this is the negatively charged electrodes because it is the cathode. Okay, so this negative charge electrode, copper is attracted to it, and copper will be present in the immediate neighborhood, and this will receive the 2 electron from the anode. Okay, and it becomes copper. Okay, this is the cathode half cell. Here the reduction potential is happening. Okay, now we are going to represent the cell. Okay, according to the IUPAC convention, there are some rules for writing a cell diagram. Here I have written the cell diagram. This is copper ions giving copper. So remember, cathode should be written first and anode should be written next. Okay, so this is E naught of cell. This is the EMF of the cell. EMF of the cell. How to find the EMF of the cell? E right hand side minus E left hand side. Okay, so what is in the right hand side? That is copper. So I have written the copper and minus the zinc. So here I have given Cu plus 2 bar Cu. So what are these things means? Look at the equation. Here the copper is present originally as copper ions. The first copper ions, the original ions I have written first, and I have separated it by a single line. Later I have given the product. What I have get after the reaction happens, that is copper. So I have written it secondly. Okay, the 2 lines indicate the salt bridge. The 2 lines indicate salt bridge. Okay, next we have to write the anode. In the anode, what is originally present? Zinc ions are originally present. So the zinc ions is written first, and after the reaction, how the zinc ions get converted? Zinc Zn plus 2. So Zn plus 2 I have written. Okay, so this is the basic EMF of cell. You have to remember. Remember, if the concentration of the electrolytes are just 1 molar unity. Okay, if the concentration of the electrolytes are 1 molar, then the potential will be called as the standard potential. Then the potential will be called as standard potential. Remember, there is no standard methods for predicting the standard potential of a half cell. So we can't find the EMF of a half cell directly. Okay, only the EMF of the whole cell can be found out. That is, this thing only we can find out that through by a voltmeter. So in voltmeter we are able to see the EMF. This one can be find out, and we are not supposed to find the EMF of any half cell. For this problem we have a solution. Okay, for solving this problem we have standard hydrogen electrode. This standard hydrogen electrode have the EMF value of 0. So, EMF of hydrogen half cell is 0. In spite of being keeping an anode or cathode, whatever may be, its value is 0. Okay, I am written the anode reaction of hydrogen half cell, half H2 plus giving hydrogen ions plus electron. Here half hydrogen meaning that is only one hydrogen atom. In cathode, H plus ions gain one electron to become a single hydrogen atom. Remember, this hydrogen electrodes are usually inert electrodes. Why we call it as inert electrode means generally platinum or gold, such metals are used to generate these hydrogen. That is, they won't react in the cell, but they will provide a surface for the reactions to happen. Okay. Now we are going to find the EMF of the copper half cell. This assume that the EMF of copper half cell is unknown. Okay, this copper is taken in the cathode. Okay, this copper is taken as the cathode and hydrogen is taken as the anode. So I have used the anode equation here. Okay, the platinum is also written because it is the platinum hydrogen electrode. Okay, now I have written the formula E naught of cell is equal to E of copper minus half of hydrogen, that is E of right hand side minus left hand side as we said earlier. Okay, so what is the electrode potential of copper, that we have to find it out. E of cell is 0.34 volt. We have to find it through the voltmeter. After finding everything, we have fixed the hydrogen electrode as 0. The value of hydrogen electrode is 0. So we are getting the EMF of copper as 0.34 volts. Okay. From this we have to assume certain consideration, that is copper is easily reduced than hydrogen. Okay, copper is reduced easily than hydrogen, so that it is placed in the cathode. And also remember one thing, by seeing the EMF value, we can say if it is having negative EMF value, then they are said to be strong reducing agent than hydrogen. Suppose if the EMF value is positive means, then they are said to be the weak reducing agents than hydrogen. Okay, now coming to the Nernst equation. So in the Nernst equation I have written the cathode equation, that is a cathode reaction in a general form. General form means I have taken as M. In spite of writing any examples, I have written just as M. The M means metal. Metal M plus N ions plus N electrons giving metal. Okay. So this is the EMF of the cell, giving EMF of cell E is equal to M plus N divided by M, RT NF ln M by M plus N. Assume the concentration of metal surface is equal to 1. Okay. So I am writing all the steps as in the previous step, and I am replacing this M alone as 1. Okay. In the next step, what I have written, this is the of course the anode part, and this is of course the cathode part. So I have written it as anode and the denominator as cathode. Okay. N is the, here the terms I have to explain. N is the number of electron, that is the number of electron transfer between the anode and cathode, that is the N. F is the Faraday of electrons, Faraday. Okay. R is the gas constant and T is the temperature. Okay. Now we are going to apply all the values. We know the value of R and T is usually in the standard measurements, that is 298 Kelvin. What is 298 Kelvin? It is the standard temperature 25 degree Celsius. Okay. So by supplying all the values, and we are going to convert this ln into log. For converting ln into log, what should we do? We have to multiply it by 2.303. So after supplying all the values, we will get a number like this, minus 0.0591 divided by 2. Okay, here I have written the zinc and the copper. What is the zinc? Zinc is the anode of the Daniell cell. Cathode, copper is the cathode in the Daniell half cell. So I have specified the example here. Okay, now this is the reaction, general reaction. A moles of reactant A plus B moles of reactant B. So all the small letters are the number of moles and the capital letters are indicating the reactance. Okay. Q is said to be the product of products divided by the products of reactant. Okay. So this is of course also called as the Kc. What is the Kc? Kc is the equilibrium constant. This is the equilibrium reaction, and we said the Kc as the equilibrium constant. E of cell is equal to E naught cell minus. So here also that is ln Q. Okay. So on supplying all the values we are getting and convert the ln into log, we will make it as 2.303 divided by NF RT log Kc. Okay, Kc is the equilibrium constant. This is the Nernst equation. Okay, all of the Nernst equation and the introduction part of the electrochemistry we will meet in the next session. Thank you.